In this section, finding slope and graphing line, we're in section 2.1 of Algebra 2. The easiest way to find slope is to use the slope formula, unless you have a graph and then you can kind of count the slope. But here is your slope formula right here. It is on your formula chart, but my recommendation would be that you memorize this. It is not that hard to memorize. The hardest thing for many of you to remember is that the y goes on top. I still have several of you that will do the math correctly, but they'll put y on the bottom and x on the top. So that is something you have to remember, and the words that help you remember that hopefully are rise, which is a vertical movement up and down, over run, which is a horizontal movement. In physics, we use the delta symbol, delta y, or in science and in a lot of math as well. It means the difference in y's over the difference in the x's, which you can see that's what you're doing. You're subtracting the y values and then you're subtracting the x values. Now we label them y2 and y1 because that means that you need to start with the same point each time. And so you can label these either way, but I would go through, if you tend to get confused, and go ahead and label them and see I made a mistake here, because the x and y have to be in the same point. So you need to be sure when you label them that your x1 and y1 are in one point, and your x2 and y2 are in the second point. Now remember, your x value is always listed first, and your y value is listed second. So the slope of this line would be 8 minus 2 over 4 minus a negative 6, which is going to be 4 plus 6. And so 8 minus 2 is 6, 4 plus 6 is 10, and we're going to reduce that fraction, so our final answer is that this is 3/5. And it's a positive slope, and what you need to remember for a positive slope, if this is your x and y axis here, a line with a positive slope always kind of slants to the right. So let me change pen color. A positive slope line would go like this. Okay. A negative slope line, still having a slope value on the xy axis, would look like this. Okay. A zero slope line is horizontal, straight across, and an undefined slope line, I'm just going to go ahead and put these out before I do these last examples. Undefined slope is a vertical line, straight up and down. Okay? So those are the slopes that you're going to encounter, and you need to be able to recognize when you find the zero and the undefined slopes. And that's what examples 2 and 3 here are. Again, we can label our points, x1, y1, x2, y2. And the y here would be negative 3 minus a negative 3 over negative 1 minus 2. So this slope is going to be 0 because this turns to plus 3 over negative 3. And that answer, anytime you have 0 in a numerator, is 0. And so that's this kind of line right here. And the equation for that line is always y equals some number. You can put b, you can put a, whatever. Y equals some number. And it's the value, because all the y values, if you plotted every point on this line, they would have the same y value. Now looking at this slope, let's just switch. We'll have x2 here, because it doesn't matter which one you label which. Okay, so now I have negative 3 minus 6 over this slope, just over here for 3. This is the slope of example 1. This is the slope of example 2. The slope of example 3 is negative 3 minus 6 over 2 minus 2, which is negative 9 over 0. You can't have 0 in the denominator and get an answer, so that's why that is an undefined slope. So this is a 0 slope, that's a kind of line. This is an undefined slope, and the undefined slope is always an x equals some number, and we're just putting a. That's a number, because the x values along that line are all the same. Now this is review for you because you did a lot of this in Algebra 1 and you should have done some in geometry. Parallel lines have slopes that are the same. So this is a reminder. And we know because parallel lines never touch. My parallel lines apparently. Anyway, if you could draw parallel lines freehand very well, they would never touch. Let's see if I can do a better job. Okay, it's really good. And so they never have an intersection, and so that otherwise their slopes on other if they didn't have the same slope, they would sometimes cross. Even if you didn't see it, it might be way out off the graph, but they would cross each other at some point or intersect. But parallel lines have slopes that are the same. Perpendicular lines form right angles to one another, and they will look like this because they form the intersection from the right angle up here. Okay. And so they are opposite, which means if it's positive, you make it negative. If it's negative, you make it positive. Reciprocals of one another. Opposite, reciprocal. Okay. Now, in this bit of homework, it's just asking, are the lines parallel, perpendicular, or neither? So to do that, you have to find the slope. So we're just for this whole column, this is going to be our x1, y1 point. These are going to be our x2, y2 points. So for line 1, for the slope of line 1, we have 2 minus 1 over 7 minus 4, which is equal to 1 over 3. Okay. For line 2, we have 1 minus a negative 2, which is 1 plus 2, and we have 0 minus 1. Okay. So we have 3 over negative 1. Well, they're opposite signs, and they are reciprocals of one another, so these lines are perpendicular. Now we go on to our next one. Go to our next page. Okay, and here we're going to graph lines. On these lines, we want, again, parallel, perpendicular, or neither. So we have x1 and y1. And x2 and y2. Okay, so we have the slope of line 1. We have negative 13 minus 1 over negative 4 minus 3. There's negative 13 over negative 7, which is positive 2. The second slope is 5 plus 8. And I should cut that and say that it was minus negative. Minus a negative 8, so 12 plus 8, and over 6 plus 1. Remember, we have to divide by the x's, and this is 13 over 7. Well, it's very close, but it is not the same. Okay? So, this is neither. It has to be exactly the same for them to be parallel. Alright, and so now we have x1, y1, x2, y2. And the slope of line 1 is 36 minus 9. And 9 over, 8 plus 1, which is 27/9, or 3. The slope of line 2 is 13 plus 8 over 9 minus 2, which is 21/7. Now these are not identical fractions, but they do reduce to be the same number. And so since that is the same, these lines are parallel. Now there's actually three formulas I want you to remember, and again I want you to memorize these. We have slope-intercept form, which y equals mx plus b. We have standard form, ax plus by equals c. And you have point-slope form. And point-slope form is y minus y1 is equal to the slope e minus x minus x1. The easiest one to get things done to graph lines is the slope-intercept form. M is your slope and b is your y-intercept. We're looking at this, y equals mx plus b. It's in that form already. You just read out your slope as -1/2. And your y-intercept is 2, which is a point, 0, 2. Okay? This number right here is your y-intercept. And remember, I want it reported when it's out of that formula as a point. So you mark your point right there. And your negative slope, you know it's going to slope this direction. And you go vertically up 1 and to the left 2. Up 1 and to the left 2. Up 1 and to the left 2. Or you can go down 1 and to the right 2, but you have to go negative in one direction when you're planning your slope. And then you draw in your line. Okay. And if you use a ruler, it's not easy. Alright, now here is standard form. This is called standard form, ax plus by equals c. In order to read the slope and the y-intercept out of that, you need to change it to slope-intercept form. So, here x plus y is equal to 3x plus 24. And then when you divide by 4 all the way across, you have 3/4 x plus 6. Divide each of these by 4. So now you know that your slope is 3/4 and your y-intercept is at 0, 6. You go up here to 6, 1, 2, 3, 4, 5, 6, and put a point. And this is a positive slope, so it's going to go this way. And you count up 3, that's your right, over your 1 to the right, 2, 4. Now, I can't go up and over anymore, but I can go down and to the left. And negative 3 over negative 4 is also positive 3/4. So I can go down 1, 2, 3, and to the left, 1, 2, 3, 4. And down 3, and to the left, 4. Okay. Should be right up there. And then I try to draw in my straight line. So there's your line for this particular point. Let's go down and finish out the page of our question. So our last page, we have 2 more graphs. This says use the intercept method, which means find x and y intercept. And when you have a line in standard form, this is actually the easiest way to find this line. Now, in the intercept, remember for the x-intercept, y equals 0. So you're on the x-axis, that's what the x-intercept means, it's where it crosses the x-axis. And no matter what coordinate of the points you have here, for example, this is 2, 0, you have 10, 0, you have negative 5, 0. The y is always 0 if it's on the x-axis. So then we can just make our y 0. We have 3x plus 5 times 0 equals 15. So that gives me 3x equals 15, because anything times 0 is 0. And so x equals 5. And so on the y-axis, so x-intercept, the actual point is at 5, 0. So we plot that point. 1, 2, 3, 4, 5. And then for the y-intercept, you always remember you must x equals 0, because no matter where you are on this y-axis, you have 0, 2, 0, 10, 0, negative 5. They're always, the x value is always 0. So now we put 0 in for x. 3 times 0 plus 5y equals 15. Anything times 0 is 0. So 5y equals 15 or y equals 3. And so the point is 0, 3. And so you do 0, 1, 2, 3 to the point. And then you can step in 3 and hit the point. Alright, again, x-intercept, you make y equals 0. So if you want to, you can just hold your finger over that, because 8 times 0 is 0. Hold your finger over that, and you have 12x equals 16. Divided by 12, x is equal to 16 itself. Divide each of those by 2, that's 8, 6. And we'll divide by 2 again, so that's 4 thirds. So the point is at 4 thirds, 0, which is basically 1 1/3, so it's about right there. Okay. Now look at the y-intercept. Remember, we want x to be 0, or x is 0 on the y-intercept. So 12 times 0 is 0, so what's left over there, you look here, we have 8y equals 16. So 8y equals 16, and y equals 2. So we go up here to y equals 2. And we try to draw a line that will go through both of those points. Okay? And that is how you graph lines using intercepts. And list these, when you do this, as a point. I don't want you to list the number, I want you to list it as a point.